Good evening to everyone. Am I audible, beta? Sure. Wave optics revision beta. Damn sure we'll get one question based on this one. Small chapter and easy chapter also. Okay. Sure. First, we'll try to talk about what do you mean by a wavefront. Wavefront is nothing but the locus of all the points which are in the same state of vibration is known as of your wavefront. Okay. The locus of all the points which are in the same state of your vibration is called as of your wavefront, and wavefront is always normal to the propagation of direction of your ray vector. Make sure of that one. Okay. Okay. What is a wavefront? Locus of all points which are in same state of vibration. I mean to say they are in same phase is called as of your wavefront. Okay. One more and very important point. Wavefront is normal to propagation, is normal to the propagation direction of your ray of light. Done, beta? Are you able to see the screen, beta, everyone? Shilpa, are you able to see the screen? Okay, chalo. So locus of all the points which are in the same state of vibration is called as of your wavefront, and wavefront is always normal to the propagation direction. That means if the ray of light is going in this direction, this is your ray of light. Okay. Now, if I draw a perpendicular to it, like this, locus of all the points which are in the same state of vibration. If I draw the line like this, and this is called as of your wavefront. This is called as of your wavefront. Okay, which is making an angle of 90 degrees with the ray. Which is making an angle of 90 degrees with respect to your A. Done? Sure. Next one. If I'm talking about your types of wavefront. Types of your wavefront. Okay. First one is spherical wavefront. The best example for the spherical wavefront is point source of light. Like say for example, this is a point source of your light from which the ray of light is going in this direction. One more ray of light in this direction. One more ray of light in this direction. One more ray of light in this direction. The ray of light is going in this direction. So this one. So if I add the locus of all the points which are in the same state of your vibration, like this point, this point, this point, this point, this one, and this one, this one, and this one. and add all of them. So we're getting what type of a wavefront? Spherical wavefront. So who will be giving you point wave, spherical wavefront better? Point source. Example for this one is your point source. Is the best example for the spherical wavefront. The next one is cylindrical wavefront. Next one is your cylindrical wavefront. Okay. So what do you mean by cylindrical wavefront? Wavefronts which are being coming from the slits, which will be in the form of your cylinder like this. Tube lights, like a slit type of instruments, will be giving the wavefront in these directions. If I attach the locus of all the points which are in the same state of vibration, that will be giving you the spherical wavefront. Done, better. Third one is planar wavefront. Third one is your planar wavefront. Planar wavefront. A ray of light seen from a larger distance will be giving you the plane wavefront. Let's say this is your ray of light, which is seen from a very large distance, So if I attach this one, this will be your plane wavefront, which is making an angle of 90 degrees. Done, better? Sure. Now tell me for this one. Now, if I'm saying about your converging ray of light, let's say if the rays of lights are converging like this. If the rays of lights are converging. So let's say this is your point, and all the rays of lights are converging right now for this one like this. Okay. So all the points which are in the same state of vibrations, like so this point, this one, this one. So somewhere from here, if I am seeing this one, okay, this is my eye, say for example, I am seeing from this particulation, all of them are appearing to be converging for me, isn't it? So that is called as of your converging wavefront like this. All the locus of the points which are in the same state of your vibration. Okay, so this will be something like of your concave, isn't it? And this will be your converging wavefront. Okay, this is your converging wavefront. Okay, one more. Diverging wavefront. Diverging wavefront. That means if the ray of light is going away from the source, the ray of light is going away from the source, that will give me what type of a wavefront? It will be giving you the diverging wavefront. Like say for example, from this source, ray of light is going in this direction. Okay, so locus of all the points which are in the same state of vibration will be giving you the wavefront, isn't it? So if I add both of them right now, these are diverging and they are going in the outward. So this will be called as of your diverging wavefront. That means something like of your convex. Done? Sure. Let me give you some example in the form of a question. Let's say for example, this is a convex lens. This is your principal axis. If the ray of lights are being incident parallelly, that means what type of wavefronts will be incident on this one, beta? Plane wavefront, like this, plane wavefronts are being incident. What type of lens it is? A convex lens. But tell me what type of wavefront will be getting, beta? What type of a wavefront I'll be getting? What type of a wavefront I'll be getting, beta? Converging. So they are meeting somewhere here right now, isn't it? So we'll be getting right now for me what type of wavefront? Converging wavefront. All of them are converging at one point. So we get converging wavefront. The question may be asked, when a plane wavefront is incident on a convex lens, when a plane wavefront is incident on a convex lens, what type of a wavefront we'll be getting? We'll be getting converging wavefront. Am I clear? Am I clear? One more example. If I'm talking about concave lens, I'm talking about your concave lens. This is the principal axis. The rays of lights are incident parallelly on this one like this. So what type of wavefronts are being incident on this one, beta? Plane wavefront. So when a plane wavefront is being incident on this one, what type of a wavefront will be getting? Diverging wavefront like this. That means the waves are moving in the outward direction right now for me. So they are right now for me diverging like this. isn't it? So this is what type of lens? Concave lens. What type of wavefront is incident? A plane wavefront. The question may ask, when a plane wavefront is incident on a concave lens, what type of wavefront will be getting? Diverging wavefront. Diverging wavefront. Am I clear, beta? One more example. Tell me the answer for this one. If we are taking a prism, the ray of light is incident on the prism like this. The ray of light is been incident on the prism like this. Okay. This is the wavefront. What type of wavefront will be getting, beta? What type of wavefront will be getting? Let's say this is slightly bending like this. And here also, right now after coming here, it will slightly blend here. And here also it will slightly blend here, right? Isn't it? So what type of wavefronts will be getting better? Here if I'm taking 1 point, here if I'm taking 1 point, here it is I'm taking 1 point. So what type of wavefront we are incidenting? A plane wavefront. So when a plane wavefront is incident on a prism, so what type of wavefront will be getting better? So if I take this one right now, locus of all the points which are in the same state of vibration. Again, we are getting plane wavefront only, but it is slightly slanted. So we will be using a word called as of your slanted wavefront. Am I clear? Am I clear? One more question. Let's say, for example, a question might be framed something like, if I'm taking a concave mirror, this is your concave mirror, and this is a ray of light which has been incident on this one. This is your concave mirror. So tell me what type of wavefront I'll be getting. What type of wavefront I'll be getting? Okay, this will be like this. Locus of all the points which are meeting here right now. So what type of wavefront? Converging wavefront. What type of wavefront is incident on this one? Plane wavefront. Now again question, when a plane wavefront is incident on this one, we are getting what type of wavefront? Converging spherical wavefront. Converging spherical wavefront. Clear, beta? One more example. Tell me the answer for this one. Now if I'm taking right now for me a lens which has been silvered inside. This is your principal axis and it is silvered inside. If it is silvered inside, this is called as of your convex mirror. For convex mirror, if the ray of lights are coming parallel to the principal axis like this. What type of wavefronts are incident on this one? A plane wavefront. So now again the question, a plane wavefront is incident on your convex lens. What type of wavefront will be getting again right now? From here the ray of light will get diverged. Isn't it? That means after incidenting on this one, this ray of light will be diverging like this. If I extend that one in the backward direction. Okay. So somewhere here right now, we are getting the wavefront like this. Going outward. So this will be your diverging wavefront. Diverging wavefront. Spherical wavefront. Clear? I hope I'm clear with this one. Shilpa, are you understanding this one? I hope you got an idea what do you mean by wavefront. So what do you mean by wavefront? Locus of all points which are in the same state of vibration is called as of a wavefront. Wavefront is normal to the propagation, that is making an angle of 90 degrees. If I'm talking about the types of wavefront, we have the spherical wavefront, isn't it? We have cylindrical wavefront, we have plane wavefront, we have converging wavefront, diverging wavefront, some of the examples. Okay, na? Sure. Next slide. Okay. Now let us try to talk about your intensity and amplitude. Intensity and amplitude in interference. In your interference. One of the very important area beta for the competitive exams. Okay. Chalo. When two waves are been superimposing each other, first thing is the first formula you need to remember in this one is about your phase. That is nothing but of your delta phi is equals to your 2 pi by lambda into delta x. Relation between phase difference and path difference. Okay. Now, second and very much important formula in this one is right now for me A net. How do you calculate the resultant amplitude? A resultant is equals to under root of your A1 square plus of your A2 square plus 2 times of your A1, A2 into your cos of your delta phi. Done? Sure. If A1 and A2 are same beta, if A1 is equals to A2 is equals to A, then A net will be equal to 2A into cos of your delta phi divided by 2. Yeah. Very important formula. So A net is equals to your A1 plus of your A2 and A net is equals to, so both of them are same, that is the relation. And delta phi is equals to 2 pi by lambda into your delta x. Am I clear? Sure. The next one is about your intensity. Intensity formula, I hope you remembered it. I resultant intensity or I net will be equal to your I1 plus of your I2 plus 2 into root of your I1 I2 into cos of your delta phi. Delta phi is your phase difference, isn't it? So if I1 is equals to I2 is equals to I naught, then I net will be equal to 4 times of I naught into cos square delta phi divided by 2. This will be your I net. This will be your A net. Clear? So I net is equals to your 4 I naught into cos square delta phi, or I resultant is equals to your I1 plus of your I2. Reason for that one is what beta? Intensity is directly proportional to the square of amplitude. Intensity is directly proportional to square of amplitude. That is I1 by your I2 will be equal to your A1 square divided by your A2 square. Clear? Sure. Next one is if I'm talking about interference. I'm talking about your interference. See, in interference, if I'm talking about, we talk about two types of interference. One is about your constructive interference. First one is about your constructive interference. Constructive interference. Represented by, or also called as of your bright point. Or also called as of your bright point or bright band. Done? See here. In this one, the first formula which you need to remember is delta phi must be equal to your 2n into your pi. Okay. And path difference delta x will be equal to n into lambda for brighter point. Okay. And A net will be equal to net amplitude will be equal to your A1 plus of your A2. That means if A1 is equals to A2 is equals to, if I'm taking A, then A net will be equal to 2 times of your A. A net is equals to 2 times of your A. Okay. The same way, I need to remember one more formula for constructive interference. That is nothing but resultant intensity. I resultant is equals to root of I1 plus root of your I2 into your whole square. Again, same condition. If I1 is equals to I2 is equals to your I naught, then resultant intensity will be equal to 4 times of your I naught. Very, very important. But by heart rate, you need to remember these all conditions. So I net is equals to I1 plus I2. Path difference is equals to n lambda. Phase difference is equals to your 2n into your pi. Very important. Delta phi is 2n pi, delta x is n lambda, a net is equal to a1 plus a2, and I resultant will be equal to your I1 root of your I1 plus root of your I2 whole square. Okay, and for this one you need to remember this one, I resultant is 4 times of I naught and a net will be equal to 2 times of your a participation. I hope you are clear with this one. Done, beta? Not going in much details because again it will take much of your time. So I'm just fastly revising the basic concepts which have been required for doing the numericals. The second type of interference is right now destructive interference. Destructive interference. Destructive interference bolo? Yeah, we call it as of your dark point, or we call it as of your dark point. Okay. Now, in this one, the thing you need to remember is again, first one, number one, delta phi will be equal to your how much? Delta phi, that means phase difference for the destructive interference or dark point will be equal to 2n plus 1 into your pi. N is your integer bit. The same way path difference, delta x is equals to your 2n plus 1 into your lambda divided by 2. Done? And third formula, a net or a resultant. A resultant will be equal to a1 minus a2. If a1 and a2 are same beta, if a1 is equals to a2 is equals to a, then resultant amplitude will be equal to your 0. Resultant amplitude will be equal to 0. Fourth one, I net will be equal to how much? I net will be equal to root of I1 minus root of your I2 into whole square. Again same, if I1 is equals to I2 is equals to अगर मैं I0 ले रहा हूँ, then net will be equal to how much? Net intensity will be equal to 0. Am I clear? Isn't it? I net is equals to your root of your I1 plus of your I2, and A resultant is equals to your A1 minus of A2. Path difference is equals to your 2n plus of 1 into lambda by 2, and phase difference is equals to your 2n plus 1 into your pi. Clear, beta? So these are the basic formulas which you need to remember basically for doing the problems of your interference part of equations. Okay, A resultant will be 0 and I net will also will be 0 in the destructive interference. Am I clear, beta? Am I clear? Chalo. Next slide. Very important, Young's double slit experiment. Young's double slit experiment. YDSC. We call it as a what? YDSE. Okay. So basic diagram for this one you need to remember. We have got a diagram like this. Small slit and a screen here right now somewhere. And this is your central axis. And here there is somewhere as a parent source. Yes. These are called as of your S1 and S2, which are coherent sources. A ray of light from this one is incident on this one, which is a monochromatic ray of light having a wavelength of your lambda. Intensity of this one is I naught, and intensity of this ray of light is also for me or I naught. Okay, S1 and S2 are right now for me the two slits. Okay, center we always get the central maxima beta. On this one we get value of C, followed by your dark, then followed by your bright, then again followed by your dark, again followed by your bright, followed by your dark, like this. Okay, C is right now for me what beta? C is your central bright fringe or bright point. B is your bright fringe, and D is your dark fringe. D is your dark fringe. Okay, the wavelength of this one starts from 0. Okay, the next one is right now for me lambda by 2. First dark is at lambda by 2, and bright is at your lambda. Then again bright dark is at 3 lambda by 2. Then again 2 lambda. The next one is nothing but 5 lambda by 2. Like this, bright and dark will be happening. Whereas intensity will be equal to, at center the intensity will be equal to I naught. Then at lambda by 2 the intensity will be equal to 0. Then here again it is maximum 4 I naught part of relation. Then again right now for me 0 dark point, again 4 times of your I naught. Then again right now for me your 0. Like that we'll be getting the intensity. That means at the center we are having right now maximum intensity. That means if I'm drawing a graph for the intensity like this, center we are having a maximum followed by dark, then again for me maximum, again dark, then this one is dark followed by this one. So this one is right now for me C, this one is bright, sorry, this one is your dark, this one is your dark, then this one is followed by your bright, this one is dark, and this one is right now followed by your bright. Okay, and equally diagram onto this, it will be equal. At the center we are having the intensity, how much for me? 0. Path difference is right now for me 0. Intensity will be equal to 4 times of your I naught. 4 times of I naught. That means at the center the intensity will be 4 times of I naught. Here also 4 times of I naught. Here also 4 times of I naught. Here intensity is 0. Here intensity is 0. At dark point the intensities will be equal to 0. Clear? Am I clear? Sure. Next one, and very important. Distance between bright and dark fringes. Very important formula beta. Okay, same diagram again. This is your slit, and here is your screen, and here is your central maximum. The ray of light which has been coming from here, from the source S1, this is from the source S2. This is meeting somewhere at this point, and this ray of light is also meeting somewhere at this point. This one is like this, this one is like this. Distance between S1 and S2 is right now for me D. This is the point where we be getting the maxima or minima. This is the point where we are getting either Y. The distance between slit and screen is capital D. This one is known as screen. S1 and S2 are slits. The distance between them is slits. S1 and S2 is small d. And the point P where we make it the maxima or minima, that is nothing but of your Y. Y is nothing but for me. Now let me talk about some basic formulas related to this one beta. Path difference at Y will be equal to how much? Delta X is equals to D into cos theta. For very small, if I'm writing directly the formula. Delta X is equals to Y into small d divided by capital D. This is the path difference in the YDSC, which you need to remember every time. So from this one, we talk about one is your dark point, and the another one is we talk about your bright point. So let us first try to talk about your bright point. First one is about your bright fringe. Then we talk about your dark fringe. Okay. So let us try to talk about bright fringe. Then we'll try to talk about your dark fringe. Now in bright fringe, delta X will be equal to n lambda, path difference. So delta X value is how much for me? Yn into your D divided by capital D is equals to n into lambda. Clear? That means what will be the value of Yn? Ynth bright point will be equal to n lambda into capital D divided by your small d. So nth bright point is being formed at a distance of your n into lambda into your capital D. The same way for dark fringe. Path difference is delta x. This delta x is equals to your 2n minus 1 into your lambda by 2. Okay, or plus also you can take, that depends upon the value of n, whether you're starting from 0 or you're starting from your one part of relation. Clear? Clear, beta? Now tell me, delta x is how much value? Yn into small d divided by capital D is equals to 2n minus 1 into lambda by 2. To simplify this one, Ynth of your dark point will be equal to your 2n minus 1 into your lambda into capital D divided by your 2 times of your small d. So this is your Ynth dark. Ynth dark is equals to 2n minus 1 into lambda into capital D divided by 2. Clear? So basic standard formulas which you should always remember. Ynth bright is n lambda into capital D into small d. Ynth dark will be equal to your 2n minus 1 into lambda into capital D divided by 2 times of small d. Path difference is at n lambda and path difference is 2n minus 1 into your lambda by 2. And path difference for the YDS is delta x is equals to your y into small d divided by capital. Done? Sure. Next one is, let us try to talk about fringe width. What do you mean by fringe width? Fringe width represented letter beta and angular fringe width. Angular fringe width. Very important formulas. Okay. What do you mean by fringe beta? Can anyone tell me? What do you mean by the fringe? Fringe is nothing but distance between two successive bright or dark fringe. Okay, and formula is beta is equals to lambda into capital D divided by small d. Okay, angular fringe width is represented by theta. Theta is equals to lambda divided by small d. Angular fringe width is represented by theta. Fringe width is represented by your beta. So theta is equals to lambda into d, and beta is equals to lambda into capital D divided by small d. Done? Clear? Okay. Now see, the fringe width will change beta if it is inserted in your water. Okay. So this is for air. In any medium, if I'm writing, okay. So for any medium, wavelength will change. So beta dash will be equal to lambda dash into capital D divided by small d. So lambda dash will be equal to how much beta? Lambda divided, because we know that as refractive index mu is equals to lambda divided by lambda dash, isn't it? So lambda dash will be equal to how much for mu? Lambda dash will be equal to lambda divided by mu. So that value I am substituting here, lambda into capital D divided by mu times of your small d. That means this value will become for me beta divided by mu. This is for your air. And this is for your any medium. For any medium, beta dash is equals to your beta of your air divided by refractive index. Done? So fringe width will change if it is inserted in any medium. Done? Next idea. Thin film in YDSC. Thin film in YDSC. That means in between the slits of S1 and S2, if some thin transparent sheet is been inserted, like mica sheet or maybe a thin sheet, isn't it? So something like this, some sheet is been inserted in this one, which is having a thickness of T and refractive index of your mu. Okay, and a ray of light from this one is being incidenting, is passing like this and will meet somewhere here, right? This is S1, this is your S2. The distance between them is small d. The distance between screen and slit is nothing but for me capital D. This is a point Y where we are getting either maxima or minima. Okay, so if I write the formula for this one, delta x will be equal to your mu minus 1 into thickness T will be equal to y into small d divided by capital D. That means y value will be equal to mu minus 1 into T into capital D divided by your small d. Very, very important formula. Don't go behind the solution right now for this one. So when a slit is being inserted, the maxima, bright point or dark point will be shifted in the upward direction by how much? So y is equals to mu minus 1 into T into capital D divided by small d. Shift in the fringe pattern. Clear? Okay. Clear, beta? So if a thin sheet of your mica or anything is being kept, shift in the fringe has been calculated by the formula capital D by small d mu minus 1 into T. Here mu is refractive index of the medium beta. Okay, now? Okay. If I tell you something like this, if shift is equivalent to n fringes, is equivalent to n fringes, then I can write here n will be equal to your mu minus 1 into capital D into thickness T divided by your D. Like say if I'm simplifying and writing this one is equivalent to n fringes, I'm telling you. So y is equals to n into beta is equals to mu minus 1 into capital D into thickness T divided by small d. So it is n into beta is equals to how much for me, beta? What is the value of beta? Beta is equals to lambda into capital D divided by your small d. Isn't it? That is equals to mu minus 1 into capital D into T divided by small d. Small d, capital D will get cancelled. So n value will be equal to how much for me? N is equals to mu minus 1 into thickness T divided by your lambda. So this will be the value of your n. If shift is equivalent to n fringes, if it is select, n will be equal to mu minus 1 into T into your lambda. Clear? I have not informed much students today, beta. So that is the reason I'm just making today by interference. Diffraction and polarization, we'll try to do it tomorrow and start doing with the numerical. Just go through the interference today and start doing the PYQs, and tomorrow also I'll start doing some PYQs related to this one. Okay, let me do one question for you. See how many of you will give me the answer. Let's say in a YDSE, the separation between the slits, that is small d, is equals to 0.15 mm. Okay, and wavelength of the source of light is given as 589 nanometers. Okay, and screen is kept at a distance of 1.5 meter. That means capital D is given as 1.5 meter. Okay, now is asking you beta value is equals to how much? Fringe width will be equal to how much? So can anyone give me the answer? In a YDSE, small d is given for me, capital D is given for me, lambda is given for me, beta is asking. Beta formula, beta. Beta is equals to lambda into capital D divided by small d, isn't it? So lambda is equals to 589 nanometers into 10 power minus 9 nanometers into capital D is 1.5 divided by small d. Small d is equals to 0.15 mm into 10 power minus 3 meters. See how much I'm getting right now for me? 0.15 बोले तो इसमें चले जाएगा ना बेटा. 0.5 this one. This will become for me 10 times. That means this value will become for me 589 into 10 power. This will be minus 5. Isn't it? So what will be the answer? 5.89 into 10 power minus 3 meters. Or else I can take this one as 5.89 as 5.9 mm. This will be the answer. Clear? So one more question. Okay. In YDSE experiment again, beta, the path difference between the two waves. Path difference matlab delta x. If delta x is equals to 1/8 of wavelength, that is lambda. Okay. Now tell me what is the ratio of intensity of light at the point to that at the center of the bright point. Okay. The question is the ratio of intensity of light at the point to that at the center of bright fringe. Then, see in various experiment at a certain point on the screen, the path difference between the two interference waves is, that means delta x is equals to 1/8 of the wavelength. The ratio of intensity of light at a point so that to that at the center of the bright point will be equal to how much? Okay, that means this is your YDSE and here is screen, isn't it? And this is your central part. This is your S1, this is your S2. These are meeting somewhere at this point. Okay, and delta x is equals to how much for me? Lambda divided by 8. This is your S1 and this is your S2, and here the intensity is I naught, and here also the intensity is I naught, and at this point the intensity is I. So if both of them are sine, I will be equal to how much better? 4 times of your I naught into cos square delta phi divided by 2. Isn't it? Then I can write this one as I divided by 4 times of your I naught. Okay, that will be equal to, this is nothing but how much for me? Cos square delta phi divided by 2. Isn't it? You know this formula beta? Cos 2 theta will be equal to how much? Cos 2 theta is equals to 2 into cos square theta minus 1. So cos square theta will be equal to how much value? 1 plus cos 2 theta divided by 2. I can use this identity here right now. So this value will be equal to how much value? I divided by 4 times of I naught is equals to, this value will be equal to your 1 by 2 into cos square theta is how much for me? 1 plus of your this one is cos square theta, that is nothing but of your 1 plus cos 2 theta. That means it will be 1 plus cos of your delta phi. Yes, na beta? Am I clear? That means this value will be equal to 1 by 2 into 1 plus cos of your delta phi will be equal to how much beta? Delta phi is equal to, we know the formula, k into delta x. K is nothing but 2 pi by lambda into delta x is lambda by 8. This one get cancelled. 2 1s are 2 4s are. That is pi by 4 will be this one. That means this value will be equal to pi by 4. Done. So that is equals to 1 by 2 into 1 plus. This will be cos pi by 4 is 1 by root 2. That is nothing but 0.7. Okay. This value will be equal to 1 by 2 into 1.7. That is approximately 0.8. Done. Good question, beta. थोड़ा mathematics लगाने पड़ेगा, but still you can do it out. Okay. So remaining we'll try to complete it in the tomorrow session of it. Okay. Bye, beta.